All right, are we streaming? It looks like it. All right, hello and welcome to my stream. This is my first stream on Twitch. So, let me start off with a little bit of background on myself. My name is Mason. I worked for the casino gaming industry for, I want to say, about 5 or 6 years. I worked as a mathematician and a game designer. Kind of how I fell into it. I've always been kind of big on math and statistics. That's what I studied. I lived in Las Vegas my whole life, and kind of living in Las Vegas and studying math and statistics, it's kind of easy to fall into the casino gaming industry. I had a pretty good gig in Seattle that I left just recently. And yeah, now I'm back in Las Vegas. I'm kind of, just kind of taking a little break. The reason I left, it was probably the best job I'll ever have, but I think it got to a point where, I love my job. It was super easy, but, and it paid pretty well, but, I think I got to a point where I saw that if I kept doing like the same thing over and over for like the next 5 years or say, my life would have been pretty comfortable, but nothing really would have changed. So, I decided to, take the savings I had and, take some time to travel. So, I left Seattle a couple weeks ago. I'm in Vegas right now, and then I'm moving to Sydney in a couple weeks. And I'm probably gonna stay there for about a year. Um, so, in the meantime, taking online classes right now in computer science through Georgia Tech. Besides that, I have a pretty strong background in mathematics and statistics and programming. So, and while I'm also taking some time off, I figured I want to stay productive. So, and I'm kind of also interested in starting my own consulting business for the casino gaming industry. So, math consulting specifically. So, I guess I could speak a little bit about that. Casino gaming manufacturers, the larger ones especially, like IGT and Aristocrat, they hire their own in-house teams of mathematicians to calculate the expected return on a game or the volatility, make sure all the calculations check out, and they can pass all the regulations for whatever jurisdiction those casino games are going to be released to. So thankfully, the larger manufacturers, they can kind of hire their own mathematicians. So, I don't know if they would need my services, but smaller manufacturers, around the world, there's a lot in Sydney, there's a few in Vegas, maybe they can't afford to hire a full-time mathematician. So, I'm just checking, kind of checking the market to see if that's kind of a niche I could fill for the industry. So, one of the things I wanted to do to kind of keep myself productive while I'm unemployed is kind of get started on my business. And the first thing I need to do for the casino gaming industry is kind of build my own kind of game simulation template. So the most popular games that manufacturers like to build are slot games. There's other games. Every once in a while someone will come up with a new card game, but by far slots are the most produced games, and there's a reason for that. They're pretty easy to build. It's pretty easy to come up with a variety of them, and they're pretty addictive. Um, I love gambling personally. I just think it's a lot of fun. It's a huge adrenaline rush, but slots personally aren't my thing, but I think they're actually pretty interesting to work on. So I'm going to show you what I'm working on right now. I kind of just started. So this is my slot simulation program. I've kind of worked on an outline. I've made a few methods so far. This is going to be I'm going to make this publicly available to a GitHub repository at some point. But let me just show you guys what I have so far. So slot game. So I'm going to try to make this as kind of as general as possible. I mean the program itself, so it can apply to a bunch of slot games. I can modify it as needed. So this is, I haven't really worked in Python. Typically, I work in C++, at least, when I worked for the industry. So now I'm trying to build my own simulator for, I'm trying to build it in Python. Just because I like working in Python. It's, I think it's really flexible, it's really easy, really nice. In C++, they have enumerators, but, I guess they don't have that in Python. So, I did a little search on Stack Exchange. It turns out you can just build a class. So this is a list of symbols. A couple wilds here. Just kind of make note of this in case someone else takes a look at this. These will be the majors, minors, and bonus symbols. Range bonus symbols. Game typically won't have. Did that cause an error? It might have. I can't comment like that in Python. All right, I'll just kind of leave it as is. Yeah, a game typically won't have 20 symbols. Maybe 10, 12 at most. But I'm just trying to make this program as flexible as possible. So let's see, and here we have some modes for the game. We have a base game, free game, and here the class called PySlot that I created. This is kind of the meat of this simulation. So I have a whole bunch of attributes for this class. Let's see, this, I'm not going to do anything with this immediately, but this Boolean variable is going to kind of track whether or not I'm doing, the idea is for it to track whether or not I'm going to do a simulation for the game, or just kind of power through, say, all the real stops of the game and kind of analyze what happens if I just, go stop by stop on a specific reel. Other attributes for a game, the number of reels, the number of rows, what kind of the screen looks like, how many symbols can fit on screen, etc. Number of lines and anti-bets. This combo pays variable is kind of what I'm going to list, is going to be an array of all the possible line wins that you can get. The reel, it's kind of self-explanatory what the reels are going to look like on a slot game, and the weights associated with that reel stopping on a certain position. So for initially I'm just going to work with evenly weighted reels, so I'm going to set all the weights to 1. But for stepper games like, say, Wheel of Fortune, those if you ever play those in the casino, for a fact those aren't evenly weighted. They just, that's just how it is. And I'm going to try it, and this is going to be what the screen looks like at any given time. This is tracking info that I'm going to output to the screen. This is going to kind of save all the information I'm interested in. The total pay, and this is squared total pay. I should add a volatility variable as well. Let's just set this to initialize this to 0. My random, and here's all the methods I've created so far. I haven't filled everything out yet. You can see a lot of these are empty, and so but let me walk through what I've made so far. I'm going to have the RNG initialized by time. This is my random function. This is just going to produce a random number from 0 to range -1. So pretty self-explanatory. Get weighted table index. So a lot of times in slot games you're pulling from a weighted table. So this is just a method to kind of get an index from a weighted table. So for example, say we have a weighted table of 1, 2, 5, and 1. More often than not, most of the time you're going to pull a value of 2, because this is the largest number, that's the largest weight in this table. So 5 out of 9 times you're going to get this second index over here. print screen, this is just a way for me to kind of, this is more of like kind of a debugging method. This just, you know, kind of prints what's going on screen at any given time. And here's just, this is just a way for me to load data from a text file for a specific game. So this is the game data, like, so here you're loading like the game data, like the reels and the pays for the game. Depending on the game, I might also add, you know, a routine for, you know, loading in weights. This, you know, load game line is going to do pretty much the same thing, except it's just going to load lines. Maybe I should combine these two, but that's how I have it set up right now. The spin, you know, spin the reels, line eval, evaluate a specific line, total line eval, evaluate all lines, count scatters, and eventually, you know, we're going to have to, once all this is put together, we're going to have a run simulation method. And, yeah, where sims equals simulations. I'm not sure how that works here. I'll just keep it simple for now. Okay, so let us come up with a method for loading the game lines. Oh, and let me go over, you know, a game I'm trying to simulate right now before I get started. So I created a game in Excel. You know, I just kind of made up some reels. You know, this is what the reel stops are going to look like. Let me do some highlighting here from those. I have used this version of Excel, but it doesn't look too much different from what I'm used to. Let's see. Highlight cells equal to. Highlight cells, text that contains WW. Okay, that just makes it a little bit easier to read. So, you know, I just created some reels here. I just made these up in my head, and I made up some pays. And this is a really simple game. It could be any number of lines. You know, let's just say it's a 20 line. No, let's just keep it easy. Let's just say it's a 5-line game. But, yeah, it has a. So how I set up this game is it'll trigger the free games. You know, pays left to right. You know, typically what you think of a slot game. How it's going to work is it's going to trigger the free games when you get 3 bonus symbols anywhere on screen. You're going to get 15 spins every time you trigger and re-trigger. And, you know, I did all the calculations, and, you know, I just got that this game is going to pay back almost 92%. So what that means is every time you play this game, on average, you're going to get back 92 cents on the dollar. So this is just kind of a toy game just to make sure my program's working. So if my program works, I should get, when I run, you know, a bunch of simulations of my game, I should get about, you know, 92%, 91.6%. So, you know, since this is a toy example, let's set this to 5 lines. And so let's just, see, how do I have lines set up? You know, let's just, you know, manually enter the lines in the code. So self.line. Looking at this line, it does not need to be a 3-dimensional array. I think it just needs to be 2-dimensional. So let's do that. So line 0, what's the offset on a specific reel? Let me do a little print here. So that's what I want. So this is what can be the lines look like. So so for a 5-year-old game, which is what I'm simulating right now, the line starts at the top of the screen. So the top row is 0, second row 1, bottom row 2 for a 3x5 line game. So 1, 0 equals, so 1, 1, 1, 1, that would be the center line. So those will be like V-shaped lines. And so center, top, bottom, 2, 2, 2, 2. Center, top, bottom, and 2 V-shaped lines. So, maybe I'll have that read from a file at some point, but for now I'm just going to enter those in manually. Now, spin. So, what we need for spin is, we need to call an RNG to pick a random stop on our reels and then set that to the screen. So, let's see, for range self.reels. We're going to pick a random stop. So how do we do that? Well, it depends on the weight of our reels. So let's, so for each of our reel stops, we need to get an index from our reel weights. So let's see, let me think about this. So stop equals self dot get weighted table index from self dot reel weights. Instead of I, let me make this more intuitive. Let's just say from reel self dot reel weights. And what kind of indices does it come up? What kind of reel weights? Does that need to be a 3-dimensional? Just, let's see how this works. Well, we need to know the current mode. So this mode just means, are we in base game or the free games? Mode and reel. So let's do a quick test. Print stop. Let's see how the spin works. Line 167. What is wrong with you? It takes exactly 2 arguments, 1 given. Test.spin node.bg. Now, why are you upset? Let's see what I'm feeding in this get weighted table index. Zeros. Oh, that's not good. self.realweights. Why is it getting zeros? Those should be ones. So I'm not getting the correct real weights. Node. Because I'm not loading the, I didn't load the game data first. Okay, so test.load game data, test.load game lines. Okay, so make sure these are always set. Make sure these are always called first. Okay, looks like it's printing out reasonable numbers. I think that's good enough for me. Yeah, so these will be the real indices. We'll just do this a couple more times. Okay, so now based on these real stops, we need to set up our screen, or we need to adjust our screen based on those real stops. So how are we going to do this? So, well, first of all, we need to know our offsets. Is the real stops adjusted for the middle row or the top row? Let's set up a new variable called offset. Let's put that real offset equals 1. So what this means is the real is adjusted to stop at the center, on the center row. Okay, so when we get a specific stop, okay, so we are going to, for row in range, self.rows. Okay. So for each row, we're going to get that specific real stop and set our screen accordingly. Is there another way I should be doing this? Now this makes sense. For row, let's see. So if the offset is 0, trying to think. Yeah. And the offset is 0. So let's see. Self.screen real row equals, and is that the correct order I've set up? I think it's reals by rows, screen, reals, rows. That is equal to self.real mode. Let's see, mode real minus offset. Is that how that's going to work? Okay, so let's just imagine, I'm not going to, be concerned with what's going to happen if the stop is at 0, because we're going to need the reals to wrap around. Let me just think about this for now. Don't worry about the case when the stop is 0 for now. So is that how that works? Stop minus offset plus rho. Does that make sense? Okay, so yeah, let me work this out on paper. Let's see. Stop minus offset plus rho. So let's see, W, A, B, C. Okay, I pull a 2. If I pull 2, my screen is going to look like A, B, C. Should I work this out on screen? I should. Okay, so let me try to explain to you what I'm trying to do here. Okay, let's say this is our real. A, B, C, D, E, F. This is our real. And let's say our RNG pulls 2. Okay. So what does this say for what gets printed to the screen? Well, our screen is going to look like, so that means, so this is 0, 1, 2, 3, 4, 5. Those are the indices for the real. Since our offset is 1, that means C is going to be centered. So this is what our screen should look like on that specific real, BCD. So what can we say about this guy? So this is going to be equal to, so this is where our RNG pulls. Let me put this over here. So this is going to be equal to, based on the variables I've set in Python, this is going to be equal to, and let me just say this is my offset, is 1. So this is equal to, so this is going to be to stop plus rho minus offset, right? Is that right? So the first row would be 2. So it would be 1, 2, and 3. I think so. Because stop is 2, minus offset is 1, plus rho is 0, so it would be 1, then rho gets incremented and incremented. So that makes sense. Okay. Well, I'm going to do something here. So I'll stop. I'll just call this R. No, let's call this X. So stop equals index. Okay, so now we need to know what happens when, say, our RNG pulls a 0. So what's our screen going to look like? Well, it's going to look like these 3 guys. So if it's a 0, so if this is less than 0, whatever this quantity is less than 0, we need to add the real length to it. 0, no, we would add, so say it's -1, yeah, we would add the real length, so we would add 6, which would give us 5. So stop, if stop is less than 0, stop plus equals self. Stop plus equals the length of that reel. Len self dot reel node reel. Should this be even called reel? Let's just call this call, because I don't want it to conflict with our. Actually, it's not going to conflict. It's just going to be confusing, but. Man, I'm already confused. All right. Call. For call. Okay. So if stop is greater than 0, or stop is less than 0, we're going to add the length of the reel so we can loop around. But what if the stop, okay, let's imagine this the other way. Let's imagine the other scenario. What if our RNG pulls a 5? Well, that's the inverse scenario. I think it's just going to be a simple modding. So that, this with the A at the bottom, that's going to be our screen. So if stop is greater than the length of the reels -1, why don't I just mod it? If stop is greater than or equal to, and stop. This is how this works in Python. Stop. Mod len self dot reel node call. Okay, let's do a test run of this. I'm not very confident that this is going to give me what I want, but let's, Oh, and we can do a self dot print screen. That's, method that I built just for this occasion. Crossing my fingers. Oh. Offset is not defined. Why is that? What did I call it? Something else. I called it real offset. So self.real offset. Real offset. Okay. Well, here instead. Well, it looks good to me. So this should be what our screen looks like. I think it looks pretty good. Let's let me print the stops as well. Print index, and just kind of do a little cursory examination. Let me do this until I get a 0, just to make sure it's looping around correctly. There you go. Okay, so on the second reel, we get a stop at 0. So let's see what our reels look like. I don't claim to be a great programmer. This probably isn't the best debugging practice, but this is what I know how to do. That doesn't look right. What's wrong here? M1, so this real stop 0. What is going on here? Okay, well, let's look at one in the middle. So this first reel has a real stop at 25. Is that printing correctly? So real stop 25, that's here, so it should be H. Oh, you know what? The symbol names are different here. So maybe it is right. Alright, this is going to confuse me, so let me make a little adjustment to what I'm exporting. I haven't shown this before, but this is kind of this is the reels and the page for the game and how I export it, but don't worry too much about that. So let's do, just so it's more consistent with what I have. Let's see, do this, fill without fill without formatting. Okay. Ew, I got a bug. What happened? Why are you angry at me? Okay, let's call this H1, H2, H3, H4. Alright, let me copy and paste this to my game data. Let's try this again. You know, this isn't necessary, but you know, this is just going to make my life a little bit easier. Where is it? It is in Xenocalculus, PySlot. Let's try this again. Just going to keep spinning until I get a 0 weight, or a 0 stop. Ah! Come on. Is there an easier way to do this? Yes, we can just set the index to 0 manually. Okay. So let's, why is it still giving me those letters? Can I change these? Let's see, where's this program? Two, 6. Why do you hate me? Ah. Aha. Aha. Try this again. Okay. So H3, M1, H1. Does that look right? H3, M1, H1. That's how it is. Okay, it's successfully looped around. Did my calculations correctly? What about if we're all the way at the bottom? What happens if our stop is 53? So we should get an H4, H3, M1. So let's see what happens for index is 53. H4, H3, M1. Alright, cool, it works. So this is my spin function. Cool. That wasn't too bad. This is going to be a little bit more difficult. Let's put this guy away. Line evaluation is a little bit more difficult. The reason for that is because of wilds. So I mean, why does that, make it a little bit more complicated to do a line evaluation? Um, so say you have three M1s and a wild. No. Let's say you start off with like three wilds, and then so say on a line you have M1, 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 wild. So in games you're always going to pay the highest win on that specific line. So your program needs to say, okay, should I pay out the three of a kind wilds or four of a kind M1s? So when you put it that way, it doesn't sound too bad. It's just something you have to watch out for. So how can we do this? So first of all, I'm going to say we're going to, let's say our line is an array. Let's call it, let's say an array of M1s. 2, 2, 2, 2, 2. Let's see. Is that M1s? This will be the simple evaluation. So M1 has an index value of 2, so that would be an array of M1s. Okay. Now let's make this a little more complicated. Let's just say it's 3 or 4 M1s and an M2. How do we evaluate this line? Let's see. I found another slot program the other day, or a slot simulation. I forget what it was called. I think it was called Bugaboom. Let's see, Bugaboom, GitHub. Let's see, what did he do? So, I don't know who this guy is, but I'm going to give this guy proper credit. I'm going to adapt some of his code for my purposes. So, hope he's okay with that. Let's see what he did. Let's see. So line win, let's see. He has a wild multiplier in his game. So first of all, he looks for a wild. I don't think this part matters too much. He looks for a wild, and if he finds a wild on the line, he's going to multiply that win by 2. So that's irrelevant for my purposes. Maybe someday I'll make a game that does that, but it's pretty simple to implement. I'm just interested in like the bare line evaluation. How does he do that? Okay, so he first looks at the initial symbol. So okay, let's just do that. Oh, let me see how my Twitch stream's doing. Do that. Oh, great. No one's watching, so that makes me less nervous. Okay, so sim equals line 0. Length of the line. Wild symbol found. Break. Why would you break? Let me look at this OBS software. Okay, it's recording. I wonder how much space this video has taken up so far. It's not going to tell me. Alright, well, I guess I'll figure it out later. My dad texted me. You can take a look at this. This is regarding, my company. I'm setting up an LLC right now. Or not an LLC, it's an S-Corp. And, I've never done this before, so he's giving me some advice on how to set it up. And, I've talked to a lawyer, he's going to do it for me, but whatever. I kind of want to be comfortable with the details. So I'm trying to figure out where I should set up the address for this company. I don't know if it should be a residential address or a P.O. box. I don't expect to get a lot of mail, but just kind of wondering how that impacts my my image, if that even matters. I don't know. I'm not really an image-based person. But, I guess, if I'm going to be doing business, maybe this is something I should be concerned about. Let's see, my dad is saying, ask your lawyer if you can put his address in the charter. So, then that's what I'll do. Alright, problem solved. Now back to this problem. How are we going to evaluate lines? Okay. Well, I think there should be two cases. If sim is equal to symbol dot w1. How do you do or in Python? Is it just the letter or Python? Sorry, I'm used to programming in C++. So this is like the stupidest thing I could be looking at, but yeah, it looks like it's just the word or. Okay. In C++ you do this, so I wasn't sure. Or sim equals symbol dot w2. Then what do we do? Okay. Line equal. Let's do count equals 0. So this will be the length of the win. So did I get a 3 of a kind, 4 of a kind? We'll start at 0. No, I guess it has to start at 1. You can't get a line count of less than 1. If sim is equal to wild 1 or wild 2, then let's see. What are we going to do? While so if the second symbol is a wild, we're going to increment our count. let's make this more too. Let's go on this combo size. Combo size. How do you do variables? Like, what's the standard practice? This standard, would you do it like this? This is like kind of a dumb thing to get hung up on, but I like to stay consistent. What do you do? What do you do? These are the tough choices you have to make. Yeah. This is where the hard decisions are made when you're designing a program. Underscore or camel case inside the method, or just all lowercase. This is something. It's probably something I'll say for my lawyer. Yeah, he'll know what to do. While line 1, or no, line count equals sin and count is less than the number of reals, less than the number of symbols on that line, and count is less than or, because as soon as it gets to the number of, as soon as we get through all the symbols on that line, we want this loop to stop, so just length line count plus, you can't do that in Python, count plus equals 1. Okay. Right. We don't call it count anymore, we call it combo size. Okay. Yeah, it looks good to me. So now we have a decision to make. Alright, does that look good? And then, let's see, then combo size is equal to wild. Combo size, what's with these gray little squiggles here? Variable and function should be lowercase. Oh, where were you? Alright. Combo size. Combo size. It made the decision for me. Wild combo size. Alright, well, I'm glad we resolved this issue. Thank you, PyCharm. Where are you mad at here? Remove redundant parentheses. Oh yeah, it doesn't. You don't need these. Are you happy? What's this squiggle? Function name should be lower. You know what? That's my decision. I'll live and die by that, so. Okay, now what? we want to keep going. So with combo size, the length of the line, then we're just going to return the pay for that. If combo size is equal to length of the line, and we're just going to return, let's see, pay you out. What do I have here? Combo pays. Combo pays, mode, symbol, size. Size, right? That sounds like it makes sense. But, you know, if we didn't get through this entire line, we need to keep going. Else. Else what? Else fucking what? Well, let's see. WSIM is equal to symbol.w2. Yeah, this is where I'll need parentheses. W2. I'm going to move this line over. Sim2 for lack of a better name. Sim2 equals line combo size. What? Well, line. Oh, this is just getting ugly. Combo size equals Sim2 or line combo size equals line combo size symbol w1 or line size symbol.w2 and do that this guy. Combo size less than line and
ugly. It's definitely ugly. Could it look better? Maybe. How? I'm not so sure. Now we need to make a comparison. Now we need to make a comparison between, those, say, 3 of a kind wilds and 4 of a kind M1, 4 or 5 of a kind M1s, for example. How do we do that? Well, we would say, okay, if pays, combo pays, self.combo pays, load, symbol, sim, and sim being wild is greater than, and W wild combo size, self.combo pays, load, sim2, combo size. Then we return this guy, else we return this guy. So we're returning the bigger of the two. What would be cool is if we return the symbol as well. That would be good for tracking. That's going to change our function up. Let's just do it. Sim2. And let's return the combo size as well. Wild combo size. Alright, I just made this. That's what I like about Python. You can do like this, return this information. You'd have to like make a, what are they called? Not static, badass. Just trust me. Returning this kind of information in Python from a function is just, or not in C++, is just a pain in the ass. I like how easy they make it in Python. This is sim combo size. Sim, so these are the 3 places with return. Let me just make sure. Sim combo size pay. This is not right. There you go. Okay, so this is the case where line starts with wilds. Else here. Case where line starts with symbol. This should be a little bit easier. Oh, man. Sorry, I'm just getting fried right here. Don't mind me. While I think it should just be the same thing as this. Right. And we don't have a sim 2 here, we're just looking at sim. Size plus equals 1. Return sim combo size dot combo pays sim to combo size. And I think that takes care of everything. I hope it does. Let me just put some documentation here. I'm not going to debug this right now. I'm a little fried. So, thanks for watching. I'm going to cut this off right now, but yeah, thanks for watching. This is my first video I made on Twitch. I kind of enjoyed it. It was actually kind of therapeutic, but yeah, have a nice day. Take care.